Section 2, fronts. When two unlike air masses meet, density differences usually keep the air masses separate. Cool air mass, a cool air mass is dense and does not mix with less dense air of warm air masses. Thus, a boundary, called a front, forms between air masses. A typical front is usually several hundred kilometers long. However, some fronts may be several thousand kilometers long. Changes in mid-latitude weather usually takes place along various types of fronts. Fronts do not exist in tropics because no air masses have significant temperature differences exist there. Types of fronts. For a front to form, one air mass must collide with another air mass. The kind of front that forms is determined by how the air masses move in relationship to each other. Cold front. When cold air mass overtakes a warm air mass, a cold front forms. The moving cold air lifts the warm air. If the warm air is moist, clouds will form. Large cumulus and cumulonimbus clouds typically form along fast-moving cold fronts. Storms that form along a cold front are usually short-lived and sometimes violent. A long line of heavy thunderstorms, called a squall line, shown in Figure 1, may occur in warm, moist air just ahead of fast-moving clouds, a fast-moving cold front. A slow-moving cold front lifts the warm air ahead of it more slowly than fast-moving fronts do. A slow-moving cold front typically produces weaker storms and lighter precipitation than fast-moving cold fronts do. Warm fronts. When a cold air mass retreats from an area, a warm front forms. The less dense warm air rises over cooler air. The slope of a warm front is gradual, as shown in Figure 2. Because of the gentle slope, clouds may extend far ahead of the surface location or base of the front. A warm front generally produces precipitation over a large area and may cause violent weather. Stationary or occluded fronts. Sometimes when two air masses meet, cold air moves parallel to the front and neither air mass is displaced. A front at which the air masses move either very slowly or at all are called stationary fronts. The weather around a stationary front is similar to that produced by a warm front. An occluded front usually forms when fast-moving cold air overtakes a warm front and lifts the warm air off the ground completely, as shown in Figure 2. Polar fronts and mid-latitude cyclones. Over each of the Earth's polar regions is a dome of cold air that may extend as far as 60 degrees latitude. The boundary where the cold polar air meets the tropical air masses of the middle latitudes, especially over the oceans, is called a polar front. Waves commonly develop along polar fronts. A wave is a bend that forms in a cold front or a stationary front. This wave is similar to the waves that moving air produces when it passes over a body of water. However, waves that form in a cold front or stationary front are much larger. They are the beginnings of a low-pressure storm. They are the beginnings of low-pressure storm centers called mid-latitude cyclones or wave cyclones. Mid-latitude cyclones are areas of low pressure that are characterized by rotating winds that move towards the air, rising in the central low-pressure regions. These cyclones strongly influence weather patterns in the middle latitudes. Stages of mid-latitude cyclones. Mid-latitude cyclones usually last several days. The stages of formation and dissipation of mid-latitude cyclones are shown in Figure 3. In North America, mid-latitude cyclones generally travel about 45 kilometers per hour in an easterly direction and spin counterclockwise. They follow several storm tracks or routes as they move from the Pacific coast to the Atlantic coast. As they pass over the western mountains, they may lose their moisture and energy. Anticyclones. Unlike the air in the mid-latitude cyclones, the air of an anticyclone sinks and flows outwards from the center of the high pressure. Because of the Coriolis effect, circulation of air around an anticyclone is clockwise in the northern hemisphere. Anticyclones bring dry weather because their sinking air does not promote cloud formation. If an anticyclone stagnates over a region for a few days, the anticyclone may cause air pollution problems. After being stationary for a few weeks, anticyclones may cause droughts. Severe weather. Severe weather is weather that may cause property damage or loss of life. Severe weather may include large quantities of rain, lightning, hail, strong winds, or tornadoes. This type of weather causes billions of dollars of damage each year. Thunderstorms. A heavy storm that is accompanied by rain, thunder, lightning, and strong winds is called a thunderstorm. Thunderstorms develop in three distinct stages. The first stage, or cumulus stage, warm moist air rises and water vapor within the air condenses to form cumulus clouds. In the next stage, called mature stage, condensation continues as the cloud rises because of dark cumulus clouds. Heavy torrential rain and hailstorms may fall from the cloud. While strong updrafts continue to rise, downdrafts from the air is dragged downward by the falling precipitation. During the final stage, dissipating stage, strong downdrafts stop currents from rising. The thunderstorm dissipates as the supply of water vapor decreases. Lightning. During a thunderstorm, clouds discharge electricity in the form of lightning. The released electricity heats the air, and the air expands rapidly and produces loud noise known as thunder. For lightning to occur, the clouds must have areas of carrying distinct electrical charges. The upper part of the cloud usually carries a positive charge, while the lower part carries mainly a negative charge. Lightning is a huge spark that travels within the clouds or between the cloud to ground to equalize electrical charges. Figure 4 shows an example of lightning. Hurricanes. Tropical storms differ from mid-latitude cyclones in several ways. Tropical storms are concentrated over a small area. They lack warm and cold fronts. Also, they are usually much more violent and destructive than mid-latitude cyclones. Tropical storms that have strong winds more than 120 kilometers per hour that spiral in towards the intense low-pressure center is called a hurricane. Hurricanes develop over warm tropical oceans. Hurricanes begin when warm, moist air over the ocean rises rapidly. When moisture in the rising warm air condenses, a large amount of energy in the form of latent heat is released. Latent heat is heat energy that is absorbed or released during phase changes. This heat increases the force of the rising air. A fully developed hurricane consists of a series of thick cumulonimbus cloud bands that spiral upward around the center of the storm, as shown in Figure 5. Winds increase towards the center of the eye of the storm and reach speeds of 275 kilometers per hour along the eye wall. The eye itself, however, is a region of calm, clear, sinking air. At about 70 kilometers in diameter, hurricanes are the most destructive storms that occur on Earth. The most dangerous aspect of the hurricane is the rising sea level, the large waves called the storm surge. A storm surge can submerge vast low-lying coastal areas. This flooding is the reason why most deaths during hurricanes are caused by drowning. Every hurricane is categorized on the Saffir-Simpson scale by using several factors. These factors include central pressure, wind speeds, and storm surge. The Saffir-Simpson scale has 5 categories. Category 1 causes least damage, and Category 5 storms can result in catastrophic damage. Tornadoes. The smallest, most violent, and shortest-lived severe storm is a tornado. A tornado is a destructive rotating column of air that has very high winds and that is visible as a funnel-shaped cloud, as shown in Figure 6. A tornado forms when a thunderstorm meets a high-altitude horizontal wind. These winds cause the rising air in the thunderstorm to rotate. A storm cloud may develop a narrow, funnel-shaped, rapidly spinning extension that reaches downward or may not touch the ground. If the funnel does touch the ground, it's generally moving in a wandering, haphazard path. Frequently, the funnel rises and touches down again a short distance away. Tornadoes generally cover paths not more than 100 meters wide. Usually, everything in the path is destroyed. Tornadoes occur in many locations, but are most common in Tornado Alley. In the late spring or early summer, Tornado Alley stretches from Texas up through the Midwest United States. The destructive power of a tornado is due to mainly the speed of the winds in the funnel. These winds may reach speeds more than 100 kilometers per hour. Most injuries and deaths caused by tornadoes occur when people are trapped in a collapsing building or are struck by objects blown by the wind.